Okay, the figure above shows a regular hexagon with sides of length A and a square with sides of length A. If the area of the hexagon is this, what is the area of the square? So one thing we can do whenever we have a hexagon is we can split it into a set of equilateral triangles. So here we have 6 equilateral triangles. Okay, and the side lengths are all A. And we know the total. Okay, so since we have 6 equilateral triangles, we can take this total area and we could divide it by 6, and that will give us the value of each. So we by 6, so 384 divided by 6, that gives us 64. So 64 rad 3 would be the value for each of the triangles. Okay? So that's the area of one of those triangles. Now, let's look at a equilateral triangle. So it has 60-degree angles. So there's 60 right here, there's 90, and if we draw this altitude, this would be 30 because it would be bisected the angle. So then, if the side length is A, then here we would have A over 2 for this segment. We'd have A for this segment. And we would have to figure out what the height is. So the height, if you remember your rule for 30, 60, 90 triangles, you have x, x rad 3, and 2x for the ratio of sides. And that can be derived with trigonometry. So basically opposite of the 30-degree angle is x, opposite the 60-degree angle would be x rad 3, and opposite the 90-degree angle would be 2x. So if 2x is equal to a, then that means x itself is equal to a over 2, which we can also see from this, and therefore x rad 3 would be a over 2 rad 3. So that's an expression for the height of this equilateral triangle. And we know that the area of an equilateral triangle, or any triangle, is base height over 2. Now the base of this triangle is A, right? And the height is A rad 3 over 2 times A rad 3 over 2. And now I have to divide the whole thing by 2, and that's going to equal the 64 rad 3 we found earlier. Okay? Well, this can be drawn across, and since we already have a denominator, we can put the 2 into the denominator we already have. Then this becomes 4. So we get a squared rad 3 over 4 is equal to 64 rad 3. And from here, the rad 3's can cancel. So we just divide by that on both sides. And we can move the 4 over to here. And now we can square root both sides. So we can actually square root these separately if we prefer. So that would give us 8 times 2, which is 16. That would be equal to A. So now the area of the square, so the length here would be 16 by 16, so that would be 256 if you multiply those together. All right, we're on to the grid ends. A coastal geologist estimates that a certain country's beaches are eroding at a rate of 1.5 feet per year. According to the geologist's estimate, how long will it take in years for the country's beaches to erode by 21 feet? So 1.5 feet in 1 year, and they want to know how many years it would take to do 21 feet. So we cross multiply, we get 1.5x equals 21, and then we can realize that 1.5 is really 3/2. So we now want to multiply by the reciprocal, 2/3 on both sides. And that would cancel this out. And 21 over 3 is 7. 7 times 2 is 14. If h hours and 30 minutes is equal to 450 minutes, what is the value of h? Well, the first thing you can do is subtract 30 minutes off of 450, so you get 420 minutes. That corresponds to h hours. And effectively what we want to do then is convert this into hours. So to convert this into hours, we need a conversion factor. And we know that 1 hour is equivalent to 60 minutes, so we just can divide this number by 60. So the zeros cancel. And how many times does 6 go into 42? 7 times, right? So we have 7 hours. In the xy plane, the point 36 lies on the graph of this function. What is the value of b? So we can plug in, remember this is y, x and y. So 6 equals 3 times 3 squared minus b times 3 plus 12. And 3 squared is 9 times 3 is 27 minus 3b plus 12. Okay. 27 plus 12 is 39. And then we subtract 6 to get 33 and add the 3b to the other side, and then b is equal to 11. In one semester, Doug and Laura combined a 250. Okay, Doug plus Laura equals 250. Doug spent 40 more than Laura. So plug that in for Doug. 40 plus L plus another L is 2L. Okay, and then subtract 40. So we would get 210, and then divide, and we get 105 for Laura. See what they're asking for, Laura. So that's finished. Jane made an initial deposit into a savings account. The equation above, okay. According to the model, how many dollars was Jane's initial deposit? $15, right? So the initial deposit would be the starting point, which is the y-intercept of the function. In the figure above, point O is the center of the circle. Line segments LM and MN, LM and MN are tangent. If the circumference of the circle is 96, all right, we could use that to find the radius. So circumference is 2 pi r. So 2 pi r has to equal 96. Divide by 2 pi, and that will tell us what r is equal to. What is the minor length of ln? So they want this arc length here. Okay. Well, let's see. Do we need the radius for that? We can also use the external angle property, right? So the outer arc minus the inner arc divided by 2 would equal the angle. And so the angle is 60 degrees. And if we multiply that by 2, we would get 120. And we also know that the outer plus the inner would have to equal 360. So we are thinking of two variables that when we subtract them we get 120, we add them we get 360. So let's say we add these numbers. We get 2O, the i's cancel, and we get 480. So that means that O would have to be 240. And if we plug in, let's say here, 240 plus inner has to equal 360. So if we subtract, we get that the inner would have to be 120. So the inner arc is 120 degrees. Okay, 120 degrees, which means that it's 1/3 of the circumference of the circle, because it's 120 out of 360, which reduces to 1/3. So it's 1/3 of the circle. So we take 1/3 of 96. So 96 divided by 3, 3 into 96 goes 3 times, then 2 times. So 32 is the result.